Now we'll come to some features of MongoDB. So these are some of the features which MongoDB provides us. First one is document oriented storage. Instead of taking a business subject and breaking it up into multiple relational structures, MongoDB can store the business subject in the minimal number of documents. For example, instead of storing title and author information in two distinct relational structures, title, author, and other title related information can all be stored in a single document called book, which is much more interactive and usually easier to work with than full index support. An index is a data structure that allows you to quickly locate documents based on the values stored in certain specified fields. Fundamentally, indexes in MongoDB are similar to the indexes in other database systems. MongoDB supports indexes on any field or subfield contained in documents within a MongoDB collection. Then replication and high availability. Replication provides redundancy and increases data availability. With multiple copies of data on different database servers, replication protects a database from the loss of a single server. Replication also allows you to recover from hardware failure and service interruptions. With additional copies of the data, you can dedicate one to disaster recovery, reporting, or backup. In some cases, you can use replication to increase read capacity. Clients name the ability to send read and write operations to different servers. You can also maintain copies in different data centers to increase the locality and availability of data for distributed applications. Then, auto sharding. Sharding is a method for storing data across multiple machines. Sharding is the process of storing data records across multiple machines and is MongoDB's approach to meeting the demands of data growth. As the size of the data increases, a single machine may not be sufficient to store the data nor provide an acceptable read and write throughput. Sharding solves the problem with horizontal scaling. With sharding, you add more machines to support data growth and the demands of read and write operations. Querying. MongoDB supports rich document-based queries. Queries in MongoDB provides a set of operations to define how the find method selects document from a collection based on a query specification. Document that uses a combination of exact equality matches and traditionals using query operator. Then we have Mapreduce. Mapreduce is a data processing paradigm for condensing large volumes of data into useful aggregated results. In this Mapreduce operation, MongoDB applies the map phase to each input document, that is, the document in the collection that match the query condition. The map function emits key value pairs. For those keys that have multiple values, MongoDB applies the reduce phase, which collects the condenses the aggregated data. MongoDB then stores the result in a collection. Last point is GridFS. GridFS is a specification for storing and retrieving files that exceed the BSON document size limit of 16 MB. Instead of storing a file in a single document, GridFS divides a file into parts, or you can say chunks, and stores each of those chunks as a separate document. By default, GridFS limits chunk size to 255 KB. GridFS uses two collections to store files. One collection stores the file chunks and the other stores file metadata. So this was about the features of MongoDB.